Yes friends, welcome once again to the class and welcome once again to the channel. And today we are going to learn about the Q value of the process in alpha decay. What is the Q value? Let us understand. So first of all, I had already told you the example of alpha decay. The example of alpha decay was as follows: that bismuth, which has atomic number 83 and mass number 212, that bismuth was getting converted to thallium. Okay, so bismuth having atomic number 83 and mass number 212 was converted to thallium having atomic number 81 and mass number 208, and in return an alpha particle was released in this process. An alpha particle was released which has 2 protons and 2 neutrons and 4 nucleons in total. So Q value of the process. Now let us understand the Q value of this particular process, the process which happened over here. Let us understand its Q value. Let us understand its Q value. So Q value of the process. Q value of a nuclear reaction is defined as. So how do we define the Q value of a nuclear reaction? How do we define the Q value of a process? How do we define it? Okay. So in order to understand how do we define it, actually I have already made a video in this particular series only. There is one video on Q value of a reaction, Q value of a nuclear reaction. I have already made a video on that, and in that particular video I had already told you regarding the Q value of the process. If you have been watching the series in sequence, then certainly you would have gone through that lecture. Okay, so anyways, even if you haven't watched that particular lecture, still I would like to tell you that Q value of the process is defined in such a manner that Q value of a nuclear reaction is defined as Q equal to Ui minus Uf. Now where to find the playlist of nuclear and particle physics for UPSC CSE physics optional? So where to find its playlist? So nuclear and particle physics playlist you will find in the link in the description of this video. There is a link in the description of this video where you will find nuclear and particle physics playlist. So certainly you can click on that playlist and you can start watching from the very first lecture. You will understand each and everything very clearly. I have started from the very much basics. And then I have moved on to the advanced level. Okay. So Q value of the process. Q value of a nuclear reaction is defined as Q equal to Ui minus Uf. So how do we define the Q value of a nuclear reaction? It is defined as Q equal to Ui minus Uf. Now what do this symbol mean? What do this symbol Ui, Uf, what do this symbol mean actually? What is the meaning of Q? What is the value of Ui? What is the meaning of Uf? Okay, meaning of Ui and Uf. What is it? So let us see. Where Ui is equal to rest mass energy of the initial constituents. Okay, so what does it mean? The initial constituents are these. Let me tell you. The initial constituents, this is what? This is the initial constituent. Okay, so Ui means rest mass energy of this initial constituent. Ui means initial energy of this constituent, which is on the left hand side. Okay, rest mass energy of this initial constituent. Okay, Ui means rest mass energy of this initial constituent, and these two are what? These two are final constituents. Okay, these two are final constituents. So Uf will be the rest mass energy of these two. Uf will be what? Uf will be the rest mass energy of these two particles taken together. So that will be your Uf. And as initial particle is only one, there is only one initial particle. So that's why the initial particle has rest mass energy Ui, and the final two particles have rest mass energy Uf. Okay. So Ui equal to rest mass energy of initial constituents and Uf equal to rest mass energy of final constituents. So you can say instead of initial constituents in local language, although that is not scientifically correct, but in the place of initial constituents you may call it what? You may call it reactants. Okay, in local language you may call it reactants, and instead of final constituents you may call it product. Okay, so these are just these things, means I would say local language, reactant product, because reactant and product are actually used in chemical reactions. The terms reactants and products, those terms are actually used in chemical reactions. Those terms are not used in nuclear reactions actually. So that's why you should actually use, instead of reactants and products, you should use initial constituents and final constituents. Okay, there is a lot of traffic disturbance over here actually. A lot of vehicles are moving over here, but anyways, no worries. So rest mass energy of initial constituents and rest mass energy of final constituents. So initial constituents are the ones which are on the left hand side of the reaction. Okay, initial constituents are on the left hand side of the reaction, and final constituents are on the right hand side of the reaction. Final constituents are on the right hand side of the reaction. So this is the meaning of UI and UF, means rest mass energy. UI means rest mass energy of initial constituents, and UF means rest mass energy of final constituents. Okay, now in alpha decay process, now where is your equation 1? Let us see. Where is your equation number 1? Let us see it. This is what? This is your equation number 1. Equation number 1 means the general equation of alpha decay. This is what? This is the general equation of alpha decay. This is general equation of alpha decay. So in that general equation of alpha decay, let us see. In alpha decay process, which is equation 1, UI, that is your initial rest mass energy of, means rest mass energy of initial constituents. Rest mass energy of initial constituents. Okay, initial rest mass energy of initial constituents. So let us see. This is the rest mass energy of initial constituents, by the way. This is what? This is the rest mass energy of initial constituents. So let us see UI. Okay, so initial constituent is XZA. Okay, this is the initial constituent. So let us look at its rest mass energy. So rest mass energy equal to mc square. You already know this. Rest mass energy equal to mc square. So mass, okay, mass multiplied by mass means mass of this XZA. Okay, let me tell you what does this particular term. This particular term is one and the same thing. Okay, this is a single term. This is a single term. MXZA. What does it mean? MXZA. What does it mean? It means mass. Okay, mass of XZA nucleus. Okay, mass of XZA nucleus. That is your rest mass actually. Okay, rest mass means, I would say, isotopic mass rather. Okay, isotopic mass. I would rather say isotopic mass of the nucleus. Okay, isotopic mass of nucleus XZA. Okay, so isotopic mass of nucleus XZA, where X is the symbol of the nucleus, A is the atomic mass number, and Z is the atomic number. Okay, so my mass numbers and isotopic mass. Let me tell you one particular fact, that okay, isotopic mass of a nucleus. Isotopic mass of a nucleus is different from atomic mass number. Okay, from atomic mass number of the nucleus. This particular fact has already been told to you. Okay, already taught in previous lectures. So you should actually watch the previous lectures, because this particular fact, that what is the difference, what's the difference between them. Okay, what's the difference between isotopic mass, what's the difference between isotopic mass of a nucleus and atomic mass number of the nucleus? What's the difference between them? What's the difference between isotopic mass of a nucleus and atomic mass number of a nucleus? This particular fact it will be taught to you. Okay, it was already taught to you, I mean. Okay, so what is the difference between isotopic mass and atomic mass number? That has been already taught, okay, in the previous lectures. So you can certainly go to the link in the description and start watching from the very first lecture. You will understand each and every concept very clearly from there, because that's how studies are done. Okay, watching any random lecture in between will not serve you the purpose. Let me tell you that watching any random lecture, okay, watching any random lecture in between without following the series is equal to epic fail, okay, in competitive exams. Okay, so watching any random lecture in between without following the series is a epic fail in competitive exams. You can clear the college exams, and that too because of internal assessment marks. Okay, you can clear the college exam, that too because of internal assessment marks, but not the competitive exam. Okay, college exam can be cleared because of internal assessment marks, even if you watch any lecture in between, but the competitive exams can never be cleared in such a manner. Okay, so let us see what is the rest mass energy. So it was the rest mass energy of initial constituents. This was what? This was the rest mass energy of initial constituents. Now this is what? This is the rest mass energy of final constituents. UF is what? It is the rest mass energy of final constituents. Okay, so let us see. So the final constituents are this particular thing and this particular thing. These are what? These are final constituents. So if you add their masses and multiply by c square, if you add the mass of this, if you add the mass of this, and if you add the mass of this and multiply by c square, what will happen? It will give you the rest mass energy of final products, final constituents. Okay, so the final two, so mass of d z minus 2 a minus 4, that is mass of daughter nucleus plus mass of alpha nucleus, alpha particle. Okay, so mass of daughter nucleus plus mass of alpha particle multiplied by c square, this will be the rest mass energy of final constituents. Now you already know that q value, how is it given? How is the q value given? So q value is given by ui minus uf. You have seen it. Q value is given by ui minus uf. So let us see. So you will do over here ui minus uf, means you will subtract uf from ui. You will subtract uf from ui. Okay, so you will subtract uf from ui. So I have subtracted it successfully. I have subtracted uf is this, and I have subtracted it from ui. Okay, and c square will be common factor between these two terms. C square will be common factor between these two terms, so it will come out of the bracket. Now this is suppose your equation number 3. This is suppose what? Equation number 3. If all the masses in equation 3 are in, what does it mean by u? Okay, so let me tell you that whether you call it u is equal to unified mass. Okay, what does it mean by u? U means unified mass. Okay, and what is atomic mass unit? AMU means atomic mass unit. AMU means atomic mass unit. Okay, atomic mass. AMU means atomic mass unit and U means unified mass. Now what's the difference between them? They are almost the same. Okay, they are almost same things. Only a slight difference might be there. Okay, only a slight only a slight difference is there. Okay, only a slight difference is there, which is not important as far as exam is concerned. Okay, which is not important for exam. So these are what? These are almost same things. Okay, almost same things. So you must remember that unified mass, whether you call it unified mass or whether you call it atomic mass unit, both the things are same things. Okay, slight difference is there, but what is that slight difference? I am not going into that. I am not going into the slight difference between unified mass and atomic mass unit. Actually, atomic mass unit was used in the olden days. Okay, actually atomic mass unit was used in the olden days. In the olden days, atomic mass unit was used when hydrogen was the hydrogen was your main means in the atomic mass of every nucleus. Okay, the atomic mass of every nucleus. Let me tell you the difference between AMU and U. Okay, let me tell you it. Let me tell this to you that AMU was used in olden days. Atomic mass unit was used in olden days. When hydrogen atom, okay, when hydrogen nucleus was used as a reference. When hydrogen nucleus was used as a reference in olden days, at that time atomic mass unit was used. Okay, when hydrogen nucleus was used as a reference in olden days. Okay, but unified mass U. Okay, unified mass U is a new concept in which okay, 1/12 of isotopic mass. Okay, 1/12 of isotopic mass of C612. Okay, new concept in which 1/12 of isotopic mass of C612 is the reference. So this is used as the reference. Okay, so in olden days atomic mass unit was used and hydrogen nucleus was used as the reference in olden days. But what about new days? Means new concept. New concept is that of unified mass, and a concept of unified mass simply says that 1/12 of isotopic mass of C612. Okay, 1/12 of the isotopic mass of C612 is the reference for measuring the isotopic mass of other nuclei. Okay, but means this is used 1/12 of atomic mass, so not atomic mass, isotopic mass. Okay, so 1/12 of isotopic mass of C612 is used as the reference for measuring the isotopic mass of other nucleus. Okay, and in olden days the mass of hydrogen nucleus, in olden days the mass of isotopic mass of hydrogen nucleus was used as a reference in olden days. But in new days, the 1/12 of isotopic mass of C612 is used as the reference. Okay, so you must remember all these things. Now what difference does it make? Okay, what difference does it make? What difference does it make? So not much. Okay, not much difference, means not significant difference, not a significant difference. Okay, not a significant difference. So in alpha decay process, now you saw all this. Okay, now in this particular equation, this is what, this is your equation number 3. Okay, now if you take the mass, okay, in q value, q is equal to mc square if you are using, and if you take the mass in kg, and if you use the velocity in meter per second, what happens? You will get the value of q in joules. You will get the value of q in joules. Okay, but if you convert it, if you want to convert it into mega electron volt, if you want to convert it into mega electron volt, then what happens? Then if you want to convert it into mega electron volt, then simply what you have to do is that take the mass in atomic mass unit or unified mass. Okay, so take the mass in atomic mass unit or unified mass, and multiply it simply by 931. Multiply it by simply 931. Then you will get the q value in mega electron volt instead of joules. So joules is a very inconvenient to handle. Joules is what? Joules is inconvenient. Joules is inconvenient to handle. Why? Because joules is a large unit. Okay, joules is a large unit. Joule is a large unit, so it is inconvenient to handle. Okay, inconvenient to handle. So that's why we are measuring it in mega electron volt. That's why we are measuring it in mega electron volt. So all the masses in equation 3 are in unified mass U. Then what happens? You will take this. Now over here this is in kg. Okay, this is in kg, this is in kg, and this is in kg. Okay, and this is in what? And this is c square is in meter per second. C is in meter per second. Okay, so in turn this will yield you joule. In turn this will yield you the unit of joule. This will yield you the unit of joule. But if you take everything in unified mass, that is atomic mass unit or unified mass in equation 3, then what happens? Suppose you take this particular thing in unified mass U, this particular thing in unified mass U, this particular thing in unified mass U, then this c square. Okay, then this c square, there is no need to put this c square over there. Then simply multiply by 931. Simply multiply by 931, and you will get the value of energy in mega electron volt instead of joule. Then you will get in mega electron volt instead of joule. Okay, so this is the thing. So all the masses in equation 3 are in, this is in U, this is in U, this is in U. Then no need of c square. Instead of c square, put 931. Then you will get the value of energy in mega electron volt. So 1 U, 1 atomic mass unit is equal to 1 atomic mass unit or 1 unified mass is equal to 931 mega electron volt. Okay, now let me tell you, 1 atomic mass unit or 1 unified mass is equal to 931 mega electron volt. Okay, now this conversion, how to do this conversion? Okay, I am giving you the homework how to do this conversion. So first of all, first step. Okay, first step, convert AMU or unified mass to kg. First of all, convert it to kg. You will get the number on internet. You can convert atomic mass unit or unified mass into kg. Okay, and then after you get the mass in kg, second step, after you get the mass in kg, multiply by 3 into 10 to the power 8 meter per second square. Multiply by the mass in kg by this particular thing. Then you will get what? You will get the value in joules. You will get the value, rest mass energy value in joules. Okay, then convert it into electron volt. How to convert joules to electron volt? How to convert joules to electron volt? Tell me. So in order to convert joules to your electron volt, you have to actually divide by 1.6 into 10 to the power minus 19. So you will divide by 1.6 into 10 to the power 19. Okay, no, you will not divide, actually you will multiply. You will multiply by 1.6 into 10 to the power 19. Okay, by this you will multiply in order to get the value in electron volt. Okay, you will multiply by this in order to get the value in electron volt. So from joule to electron volt, in order to convert joule to electron volt, you will multiply the value obtained over here in joule by 1.6 into 10 to the power 19. So you will get the value in electron volt. And then in order to convert electron volt into mega electron volt, what will you do? In order to convert electron volt into mega electron volt, you will divide this electron volt by 10 to the power 6. This electron volt you will divide by 10 to the power 6. Okay, then you will get the value in mega electron volt. So in this way you can find this relation. This is your homework. Okay, this is your homework. So one unified mass or one atomic mass unit is equal to 931 mega electron volt. So successfully we have got the Q value like this. Q value we have got like this, and this is suppose your equation number 4. This is, let's suppose, your equation number 4. Then what happens? So now comes the kinetic energy of products part. Okay, so you have successfully actually found the Q value. Okay, you have now the kinetic energy of products onwards we will do in the next class. Okay, the kinetic energy of products onwards, this from there onwards, kinetic energy of product onwards we will do in the next class. Okay, kinetic energy of products onwards we will do in the next class. Okay, but as far as this particular equation is concerned, you have to remember this particular equation. This particular equation you have to actually remember. Okay, so that's how the Q value is found. That's how the Q value of the reaction, Q value of alpha decay or any other nuclear reaction, Q value of alpha decay or any other nuclear reaction is found in such a manner. Okay, so in this way you can find out the Q energy, and numericals based on this concept might be asked to you in the UPSC examination. Okay, UPSC physics optional examination paper 2, numericals based on this particular concept, might be asked to you in the examination. Okay, so you must be ready with your concepts. Now we will learn about kinetic energy of products, but about it we will learn in the next class onwards. From the next class onward we will start the kinetic energy of products. So the end screen of this video will be nuclear and particle physics playlist. So you can certainly watch from the very much beginning and understand each and every concept very much clearly from there. Okay, so thank you very much. Jai Hind, Jai Bharat.